we're going to look at some more velocity and acceleration problems. So let's look at the following example. Let's sketch the path of an object moving along the plane curve given by r of t, which is t squared minus 4i plus tj, and find the velocity and acceleration vectors when t equals 0 and t equals 2. So let's start with what I'm asked for first, is sketch the path of this curve, this object moving along this curve. So we're going to translate these back into parametric equations again. So x will be t squared minus 4 and y will be t. What I can do is plug in my second equation into my first one to produce the equation x equals y squared minus 4. This is the equation, this is a rectangular equation. And it's the equation of a sideways parabola, sideways facing parabola. So I can sketch this curve here. Let's see, so here you go. And so the parabola goes like that. And this object, how is it moving along this curve? Well, it's moving, if you see y equals t, so as t gets bigger, y is getting bigger, so you're going upwards in terms of y. So the object is moving upwards through the curve. Okay, so now what it wants me to do is find the velocity and acceleration. So let's find the formula for velocity. I got to take the derivative of my position vector up here. Take the derivative of that, you'll get 2t I plus j. And to get acceleration, we take one more derivative. It'll just be 2i. And then this j part, it's just constant, so the derivative would be 0. So now I'm going to plug in my two values of t. T equals 0. You get j for the velocity, and the acceleration, you get 2i. And then when t is 2, you plug it into your velocity, and you'll get 4i plus j. Plug it into your acceleration, and it's 2i. So you can look at these kind of graphically here on the graph. So when t equals 0, you're at this point right here on the curve, and velocity is moving 1j, so it'll be, this is the velocity, and then the acceleration is 2i, so it's moving in the positive x direction too. So there's the acceleration at 0. When t is 2, and t is 2, you're at this point right here. When t is 2, the velocity is moving 4i plus j. So 4i plus j, it's moving right there. There's my velocity. This would be v of 2. but the acceleration is the same. It's still going to be 2I, the acceleration at 2. Let's look at one more velocity acceleration problem. So let's look at find the velocity and acceleration vectors when t equals 1 for an object moving along the space curve C given by, so the equation will be r of t is ti plus t cubed j plus 3tk, and t is greater than or equal to 0. So I need to find velocity and acceleration, the vectors first. So let's find v of t. Take the derivative. You get I plus 3t squared j plus 3k. And now find acceleration. Take one more derivative. You'll have 0I plus 6tj plus 0k. So then all I need to do is ask for the velocity and acceleration when t equals 1. So I just got to plug in 1 into these equations here, and you'll get, for the velocity, you'll get I plus 3j plus 3k. For the acceleration, you'll get 6j. And there are my two answers that I was asked for.